To find the slope of a function's graph, or the slope of the tangent line, we use the limit definition of the derivative. The slope of the tangent is the first derivative of the function, which is defined as the limit as h approaches 0, f of x plus h minus f of x all over h. So to do that for number 2, our function g of x now, instead of f of x, will look like the first derivative we need the slope of this tangent line to make an equation for that line, which is the first derivative, in this case g prime, which is the limit as h goes to 0 of g of x plus h minus g of x divided by h. So now we need to construct those parts, g of x plus h and g of x. So the limit as h approaches 0, g of x plus h is 8 over x plus h squared. We simply substituted x plus h where x was in the original function, minus 8 over x squared, which is just g of x, just the original function, and then all of that divided by h. I prefer to write that this way, the limit as h approaches 0 of 1 over h times 8 over x plus h squared minus 8 over x squared, just so I don't have fractions in my fractions. Now I need to combine those two terms so that I can simplify them and hopefully take this limit, but you'll notice right now substitution is no good, so we have to work on it a little bit. To do that we need a common denominator, so we'll multiply this first fraction by x squared over x squared, and the second fraction needs to be multiplied by x plus h squared over x plus h squared. Those are multiples of 1, so it's just changing the way that the fractions look so that we can put them together with a common denominator. This gives us the limit as h approaches 0 of 1 over h times 8x squared for the numerator minus 8 times x plus h squared all over the product of the two denominators, x plus h squared times x squared. Now we can clean up this numerator. Hopefully some things cancel. The limit as h approaches 0 of 1 over h times 8x squared minus, and before we make the distribution here, we need to FOIL these terms. So foiling that is x squared plus 2xh plus h squared, and all of those values multiplied by 8 over x squared times x plus h squared. So that's the limit as h approaches 0 of 1 over h times 8x squared minus 8x squared minus 16xh minus 8h squared. That's from the distribution of negative 8 over these three terms that came from the FOIL. And all of that will be divided by x squared times x plus h squared. Then we simplify, the x squareds go away. That's very nice. I prefer that, in fact, for it to get smaller. And we'll take out an h in the next step. So these two terms share an h, and that's what we want to cancel with this h, which is down here, so that we can evaluate the limit. So we could take out the whole GCF, which would be negative 8, or we can just take out the h, whatever makes you feel comfortable. In class, I believe we just took out the h. That would simplify for us, leaving negative 16x minus 8h over x squared times x plus h squared. So just eliminating that one h allows it to be canceled, multiply and divide by the h. So now we have a limit that we can evaluate just one more time, because why not? H approaches 0. Negative 16x minus 8h over x squared times x plus h squared, where h is going to 0. Now, finally, we can make that substitution. Each of these h's is 0. That term will be 0, and that term will go to 0, leaving us now negative 16x over x squared times x plus 0 squared, or x squared. So that's negative 16x over x to the 4th. Finally simplified as negative 16 over x cubed. Now if you remember way back at the beginning, this is the slope of the tangent line, or the derivative of that original function. Now that's going to be different based on different values of x, so we care where this happens. So we go way back up to the beginning and see where we are located. We're at 2, 2, so when x is 2, that gives us the slope of the tangent when x is 2 as negative 16 over 2 cubed. 2 cubed is 8. Negative 16 divided by 8 is negative 2. So now we can write the equation of the tangent line. Where the slope of that tangent is negative 2, and the point on that tangent line is 2, 2. So we talked about the point slope form of a line, the y minus y1 equals m times x minus x1. We now have m and x1 and y1, so y minus 2 is negative 2, the slope, times x minus 2, which simplifies to be y equals negative 2x, distribute plus 4, plus another 2 if we move this 2 over. So negative 2x, negative 2 times negative 2 is plus 4 here, and then add this one over here also is the plus 2. So yeah, simplify that. Y equals negative 2x plus 6 as the equation of the tangent line by using the limit definition of the derivative.